Welcome back to 8.5 Notes. We're going to be talking about hyperbolas again, so if you haven't watched 8.4, you're going to want to go do that first. In this one, we're going to be talking about how to write the equations. In 8.4, we talked about how to graph them. That's why you want to watch that one before this one. One of the things that we talked about was the difference between a horizontal and vertical hyperbola. A vertical hyperbola looks something like this, where it's going up and down. A horizontal one goes side to side like the second one. On a horizontal hyperbola, x goes first. And x and y both have this minus h and minus k part because that is the center. And x goes first in a horizontal one, and in a vertical one, y goes first. And they both have a fraction. The fraction is always going to be a squared, b squared. Like that. Now you might be asking, okay, well, what are a and b? How do we find them? Good question. A comes from the vertices. So the vertices are always a. The co-vertices are always b units away from the center. So the vertices are the ones that the line actually goes through. So these two are my vertices. The edges of the box this direction and this direction are my co-vertices. Then there's this other thing called the foci. They are c units away from the center, and they mainly use this right here. So c squared equals a squared plus b squared. The only reason why we need this is to find a or b if one of them is missing. So if you only know one of these two, we use this to find the other one. In order to write these equations, you need three things: the center, a, and b. Once you have those three things, it's just a matter of putting everything back into the equation where it's supposed to go. And then one last thing that's going to be probably a little bit tricky for some of us is deciding which one of these two we have. The easiest way to tell is whichever variable changes for the vertices goes first. So since the vertices are going up and down, that's changing the y value. That's why for this one, y is going to go first. On this one, the vertices are to the left and to the right. That's changing the x value, so x is going to go first. Let's jump right into writing the equation of these graphs. And I'm going to zoom in a little bit. The first thing you need to do is find the center. And then we'll find A and we'll find B. Okay, so the center is in the middle of everything. Let me go ahead and do this really quick. There you go. The center is right here in the middle between these 2 points, or right here in the middle between the two edges of the box. It's all just the center. That is the point 0, 0. For the A value, look at the 2 points that are on the curve, here and here. Those are both 1 away from the center. So A is 1. B is how far away we are from the center this direction. So that's 1, 2, 3, 4. Okay, now let's set up our fractions. A always goes first in a hyperbola, and it always equals 1 at the end. So a squared is 1, 4 squared, is 16. Don't forget to square it like I just did. So these two always get squared to come down here. Then we have to decide which one goes first. Since the vertices are on the y values, up and down, y goes first. And since it's 0, 0, I don't have any numbers on top with x and y. And that is my equation. Another way of writing this, if you wanted to, would be like this. You don't have to have the over 1. And I'm mainly doing that so that you know that if you ever see it like this that doesn't have a denominator, that's because it had a 1 on the bottom. All right, let's talk about the next one. Starting it the same way, we've got to find our center, our A, and our B. The center is right smack dab in the middle of these 2 points, which is right here. My origin was right here. So that's over 1, 2, 3, 4, 5, down 1, 2. So 5, -2 is my center. A is the distance between the center and the 2 points that have lines going through them, these 2. Those are 1, 2, 3 away. B is just the edge of the box where you don't actually have a point there. So that's 1, 2, 3, 4, 5, 6, 7. Going to come down here. A squared goes underneath the first fraction. B squared goes underneath the second fraction. A always goes first. B always goes second. Then, on top, since this 3 was changing the x values left and right, the x part of the center, 5, is going to go on top here with x. Just make sure that you flip it because the center is always the opposite of the numbers in the parentheses. So since this was 5, this is x minus 5. And then over here is going to be the y, and it had a value of -2 in the center, so that's going to become +2. And that's it. There's no other way to write this equation. It's just like that. Moving on, let's see what happens if we don't have the graphs. So instead of counting it on the graphs like I did with my pen, we're just going to kind of almost mentally count. So we still need the same information. We need the center, we need A, and we need B. So for the center, you can either find the middle of these 2 or the middle of these 2. They're the same thing. So halfway between 5 and -5 is 0. Halfway between 0 and 0 is 0. Same thing over here. Halfway between 0 and 0 would be 0. Halfway between 2 and -2 would be 0. Then for A, you're always using the vertices. From 0 to 5 is a distance of 5. And then underneath, I'm going to write x, because that's the variable that's changing. The x values are changing on the vertices. That's what I meant when I said whichever variable changes for the vertices goes first. B is the distance between these 2. Now, the zeros are the same, so that's not the part we need, but from 0 to 2 is 2. The distance can't be 0, so if you get 0, look at the other variable. That one was changing the y's. A squared goes under the first parentheses, and B squared goes under the second parentheses. And since I said that x was the one changing with the 5, x squared goes above the 25, and y squared would have to go above the 4. That's it. All right, let's try another one very similar to that one, except for the center isn't 0, 0. Okay, so halfway between 4 and 4 is 4. Halfway between 8 and -8 is 0. Okay, and then we need to find our A and our B. A is the distance between the center and the vertices, but the 4's are the same, so that automatically means the y's are going to be the ones changing. from 0 to 8 or from 0 to -8 is a distance of 8. We don't really care if there's a negative there because we're about to square it and cancel out a negative anyway. B is the distance between the center and the co-vertices. So you'll notice on this one, the x's are changing from 4 to 1. That's a distance of 3. And that's the x's. A always goes first, so 8 squared goes under the first fraction. 3 squared goes under the other fraction. It always equals 1. And since this was the y values changing, y goes first. But the y part of the center was 0, so it's just y squared, no parentheses or anything. Over here, we're going to put the x's. That was a value of 4 for the center, so we're going to put x minus 4 squared in there. And that's all. So if you understood how to graph hyperbolas, these really aren't that different. Okay, we've got 2 examples left, but you'll notice that both of these have foci in them. That means you're going to have to use this formula. Okay, so I'm going to go ahead and make my list a little bit lower this time. I need my center, I need my A, and I need my B. I need my center, I need my A, and I need my B. Those are the 3 things you need to write the equation. So for my center, halfway between 1 and -7. Well, that's a distance of 8, so if I go halfway, I would be moving 4. 1 minus 4 is -3. Or, if you don't like that, 1 plus -7 is -6, divided by 2 is -3. We call that averaging, where you add the 2 numbers together and divide by 2. Halfway between -9 and -9 is just -9. Okay? Then the vertices give me A. These points, the -9 is the same. It's the x's that are different, and they're 4 apart. What I don't know yet is B, because I don't have the co-vertices like I did on the top 2. So what I'm going to do is figure out what this one is. That's going to tell me what C is. So between the center and this point, from -3 to 2 is 5. So what I have now is C and A. So I'm going to rewrite this formula as 25 equals 16 plus B squared. Because 5 squared is 25, 4 squared is 16. Then I just subtract that 16 to the other side. 25 minus 16, B squared equals 9. So B would have to be 3. And since this is x, this is going to be the y. Now, if you get a number that doesn't have a nice square root, don't worry too much, because when I come down here to put these back in the equation, which always sets up kind of like this, fraction minus fraction equals 1, A squared goes on the bottom, and B squared goes on the bottom. So you're just about to make it B squared again. So you can almost skip writing this out if you want to. Then, since A was my x values, x is going to go on the top. And it's going to be x plus 3 because the x part of my center was -3. That always flips. Which means this will be y plus 9 since the y part of my vertex, or my center, sorry, was -9. That's it. Is this one a little bit more difficult? Yes, because you have to do this one little thing right here. Don't let that stress you out though, because it's really not that different. Okay, one last one. Halfway between 5 and -7. That's too far for me to count, so I'm going to go ahead and average them together. 5 plus -7 is -2, divided by 2 is -1. Halfway between -3 and -3 is -3. This time, I don't know what my A is because I have the covertices. Vertices are missing. We don't know them yet. So we have A is missing, but we know that B is between here and here, from -1 to 5 or from -1 to -7. Both of those are 6 away, and that's the x variable because the first part of the point is changing, and the first part of the point is the x value. The y part of the point is all -3, so there's no distance there. So we know that B is 6, and we know over here that C from -1 to 1 is the same, so that's not the distance we're looking for. From -3 to 7 is 10, so C equals 10, which means if I plug in C squared and B squared, 100 equals A squared plus 36. C squared is 10 squared, that's 100. B squared is 6 squared, that's 36. And then I just subtract that 36 to the other side, and I get A squared equals 100 minus 36 is 64, so A would be 8. And by default, since this was my x's, this is my y's. So when I go to write my equation, here's my setup. Fraction minus fraction equals 1. A squared goes on the bottom of the first one, that was the 64. B squared goes on the bottom of the second one, that would be 36. And on the top, since y is with the A, it goes on top of the 64. Because this 8 was a change in the y's. We couldn't really see it up here. It was on the vertices, which we don't have. So I need to put y here, and the y part of the center was -3, so it's going to be y plus 3. The 6 was with the x's, so it goes above the 36. And since the x part of the center was -1, I put plus 1. So pretty much you find your center first so that you can calculate a and b. A squared goes under the first fraction, b squared goes under the second fraction, and to decide which variable goes where, look at whether it was the x values or the y values changing. Since this 6 was a difference in the x values from 5 to -1, or from -7 to -1, that's why the x's went on top of the 36.